Welcome, I'm David Pomeranki, professor at the Institute of Electronics, and today we're going to make a little introductory video for our lab experiment in the EMC class. This experiment is about electrostatic discharge. It has two parts. One is the charging part, so how charges are created, how high are voltages, and the other is the discharge part. So right now we're doing the charging part. In the charging part, we're going to use an instrument to measure voltage on people. This is the instrument. The instrument is attached to the shoulder, to the body here. It's attached like this. And it has a field mill here to measure electrostatic voltage. Now the instrument attaches to an app. And the app tells the voltage on the person in this moment. We're going to use a field mill. You need to find out what is a field mill. What is it? How does it operate? Now, this is the body, and here's the sensor on. Now, if the electric field lands on here, the sensor can determine the field strength. So the sensor can determine the field strength, let's say 10 kilovolt a meter. But it doesn't know the voltage. It can only estimate the voltage. The reason is the following thing. If we are in a big room, the metal wall is far away. So if I'm charged at 1000 volt, the field strength at the sensor is small. But think about the same. Here's the room. And now I'm standing close to the wall. And then, of course, the field strength is really high. So the estimation of the voltage would be wrong. Nonetheless, this is just one part of this imperfection. So now let's see how we can do some experiments. So I'm standing on some styrofoam, and I'm rubbing a little bit. So what voltage do we get? Minus 2 kilo. Now I jump. It should go up because I changed my capacitance. So I will rub my back on the chair and then stand up. Because of the friction between my back and the chair, I will charge up, and now we may get or may not get some voltage. So what do we get? So we are going to do a set of experiments about charging up to see what voltages we get, different materials, different chairs, different clothes, different shoes. This is to give you an idea about what voltages to expect and what situation will create rather high voltage. This part of the experiment is rather exploratory, so you'll have a lot of fun. Okay, welcome. This is part 2 of our little introduction to the ESD laboratory. This is about the measurement of discharge currents from ESD. And we're going to use the test setup, which is in the chamber. We're going to see it in a second. It consists of an oscilloscope. The oscilloscope has 50 ohm input impedance. And then we have an attenuator, a 6 dB attenuator. We have a coax cable, like 2 meters. We have a 20 dB attenuator. And we have a current target. It measures the current because it has a resistor of 2.08 ohm to ground. And if you look at 2.08 parallel 50, you see it's exactly 50 ohm. So this is how we measure, and this target can handle high voltage and high current. So think about, if we have, let's say, 1 volt at the oscilloscope, let's say we have 1 volt here, yeah? This is 6 dB attenuator, so 6 dB is double voltage. We would have 2 volt here. And here's 20 dB attenuator, so it's 10 times voltage, so that would be 20 volt here. And the impedance looking into here, is 2 ohm because of this calculation. So 20 amps means 20 volt means 10 amps. So this is a very simple calibration of the system. The system is here. So here's an ESD generator. And the ESD generator right now is set to 8 kilovolt. And we just turn it on. You're going to see in the lab how to turn it on. It's really easy. Then I'm going to connect the ESD generator here to the target, to the center of the target. And I'm using right now contact mode. I don't use air discharge mode. For air discharge mode, we would have a spark. Now we injected the current into this target, and the resistance from the center to the outside is 2 ohm. The current goes to the inside. Here's the output of the target. Here's 20 dB attenuator. Here's the cable. Here's 6 dB. And the little green thing here, that's a protection device to protect the oscilloscope against ESD. Now we will discharge into a target, and you're going to see the waveform. So this is a discharge pulse from an ESD generator in contact mode. And we have 1, 2, about 3 volt. So we're about 30 amps right now. And the time scale, we have 50 nanoseconds, 100 nanoseconds. So the pulse is 150 nanosecond long, and initially high, low, and then another peak. Now let's look into the pulse a little bit more in detail. So now we are at 10 nanosecond division. So the first pulse is about 5 nanoseconds wide. Then comes the second. Now let's look at the rise time of the first pulse. Now we are 1 nanosecond division. So the pulse rises in approximately 1 nanosecond. It rises from 10% to 90% in approximately 1 nanosecond. This is the typical pulse which follows the ESD standard. In the lab, we will make a lot of different discharge scenarios, discharges of humans, discharge from ESD generators, and we will compare all of them and analyze them along the voltage to current. Does it repeat well? Does it not repeat well? Rise time, and a lot of variation studies we'll do. This will be the ESD lab. Thank you.